Hello everyone, this is problem 4 in the problem set 6.6. In this problem, they give you exponential distributions, and in this context, the average waiting time mu value is equal to 4.5. In part A, they ask you to calculate the probability that the customer will wait between 3 and 5 minutes during the checkout time. They want you to calculate the probability of t between 3 and 5. So, this is equal to the definite integral from 3 to 5 of f of t dt, and f of t is the probability density function for exponential distributions. And if you remember in class, the probability density function for exponential distribution is that k times e to the minus kt when t is greater than or equal to 0 and 0 otherwise. So in this problem, the job is now to calculate the value of k using the information that they give you, which is the value of mu. And mu is equal to 1 over k, which is equal to 4 over 5. And from here, we can get the value of k, which is 0.22. So the probability density function is now written as f of t equal to 0.22 times e to the minus 0.22t when t is greater than or equal to 0 and f of t equal to 0 otherwise. So you're going to substitute this part of the function into the definite integral, and then you can use the calculator to get the value of that definite integral. So let's work that together. So this is equal to the integral from 3 to 5 of 0.22 times e to the minus 22t dt. And if you use the calculator, the option to math 9, the result for this definite integral is 0.184 or 18.4%. So this is part A. Let's move on to part B. So in part B, they ask you to calculate the probability that the customer will wait in line for more than 10 minutes. So that is the probability of t greater than 10. So this is equal to the integral from 10 to positive infinity of the probability density functions. And the probability density functions we already found that in part A, which is equal to 0.22 times e to negative 0.22t when t is greater than or equal to 0 and f of t equal to 0 otherwise. Right? So we're going to substitute that into the integral. We have 0.22 e to the minus 0.22t dt, and from here the job is to calculate the value of the improper integral. To do that, let's rewrite this improper integral as the limit of definite integral. As I mentioned in class, there are two ways to tackle this problem. The first one is numerical estimation, and the second one is the algebraic manipulation. Let's try to do numerical estimation in this case. So I'm going to make a table, and this is n, and this is the integral from 10 to n of 0.22 times e to the minus 0.22t dt for n equal to 100, 1,000, and 10,000. So using the calculator, I could be able to get the value for the table. When n equal to 100, I get 0.1108, and then so on. So because the number 0.1108 occurred 3 times, so I had to stop my evaluation. And the probability now is equal to 0.1108 or 11.08%. So in part B, the probability of the customer wait in line for more than 10 minutes is 11.08%. That is problem 4. Please let me know if you have any questions.